For the 11th problem of this first ACT practice test, students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance d feet the cart was from a reference point at 1 second intervals from t is equal to 0 seconds to t equals 5 seconds. Which of the following equations represents this relationship between d and t? So with this type of problem, there are a couple different ways that we can approach it, though in this video, I will teach you the fastest way, or at least the fastest way that I know of, to solve this problem. So one of the nice things about multiple choice tests is that you can get a preview of what the answers will look like. So notice, all of our answers are d is equal to something, where on the right-hand side, we have some term with t in all of these equations, and some term that's just some constant. And notice that in all of these, t is multiplied by some coefficient, where in this first case, the coefficient would be 1. But in all of these, t has some kind of coefficient multiplied by it. So all we need to do is figure out what this fixed value would be and what this coefficient would be, and then from there we can eliminate all of the wrong choices. So to start, let's look at our chart, or this table here, and notice that when t is equal to 0, the distance is 14. So in all of these equations, if I plug in t is equal to 0, here, 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 or any of those places, then that would essentially make this whole term vanish, since 6 times 0 is 0. So when t is equal to 0, all of these would go away, and we're saying the distance should be 14. So that leaves us with choice A and choice C. So the other ones we can actually just cross out. So now that we've narrowed this down to just A and C, we know they have the same fixed term at the end, this 14, but now we just have to figure out what the coefficient on t is. And our clue is that we're dealing with a constant rate in this equation, and what that means is that for every second, the same amount of distance is going to be increased. So notice that from t is equal to 0 to t is equal to 1, that we go from 14 to 20. And then from 1 to 2, we go from 20 to 26. And what you can notice is that we just added 6 each time. So every step, you can continue this, we're just adding 6. So essentially our rate, this constant rate, is 6 feet per second. And only one of these equations actually has that information within it. And that would be choice letter C, since every second, notice if I put in t is equal to 2, then I'll have 6 times 2, which is 12. So I'd be adding 12 there because we've gone 2 seconds past the starting point. And the point to take away from this is that every time I increase t by 1, our distance goes up by 6. And you can test this equation just to make sure it's correct by plugging in one of these values for t. So let's plug in for t is equal to 4 and see if we get back a distance of 38. So for d is equal to 6t plus 14, we're plugging in t is equal to 4, so that our distance is 6 times 4 plus 14. 6 times 4 is 24, plus 14 brings us up to 38. So our test came out correct, which means that choice C is in fact the correct answer.